Okay, welcome back. We create models by defining the parameters, formula, and decision variables. And once we have our model set up in Excel, there are tools we can use to do various types of analysis. And we just looked at using a data table. Let's look at some other tools. So goal seek is something that allows the user to determine the value that will of an input cell that will cause the value of an output cell to equal some specified goal. So for example, looking at the Anl data set and model that we have in our Excel worksheet, we know that for a bid price of $3.50, there's some quantity between 150,000 units and 175,000 units where savings from outsourcing goes from positive to negative. Somewhere in this range of quantity, the savings to outsourcing is 0. And that is the point where Anl would be indifferent to manufacturing and outsourcing. So we can use the goal seek function to find that particular value. So I'll go ahead and open up our worksheet, and it'll look something like this. And there it is. So now in this particular scenario, what we want to do is find out at what quantity our savings due to outsourcing is equal to 0. So we'll go ahead and go to data, then what if analysis, goal seek, and we're going to set cell B17 equal to 0. That's the formula for savings due to outsourcing. And we're going to do that by changing our decision variable B11, quantity. And I click OK. And so Excel then churns through and finds out that at a quantity of 156,000, we have a break even, or in other words, the savings due to outsourcing is 0. And of course, here we see our particular model, and we put the values in as indicated. And then here's the results. The savings due to outsourcing in cell B17 is 0. And the quantity that was set by goal seek is 156,000. So when the annual quantity required is 156,000 units, it cost $564,000 to either manufacture the product or to purchase it. We've already seen that lower values of the quantity favor outsourcing, and beyond 156,000, it becomes cheaper to manufacture because we've amortized the fixed cost over a sufficient base. Scenario Manager is another tool that lets us set up different scenarios for the parameters that we're going to have in our model and see how that changes the outcomes. So let's go ahead and give a demonstration of this. And here's Excel. Okay, so we've got our model, and this is a model for making money at an amusement park, and it's based on admission price, and then the number for the season admits, the number of admits, the average expenses for the season, the average expenses for the admission, cost of operations, cost of goods, and then we have admittance revenue, seasonal revenue, admittance spending, overall revenue, and we see different formulas for adding these up, and then a total profit. So we have a model set up, and we're going to use B6, B9, and B11. So B6 is the number of seasonal admits. B9 is the average expense for admits, and B11 is the cost of operations. And we're going to change those according to different scenarios. So if we look over in data, what if analysis, and scenario manager, we have different scenarios. And basically you just give the scenario a name, and then you say you're going to give it certain values, and B6 through B9, and then B11. And then you can put the values in for that scenario. So 3,000, 1,600, 15, 45, and 33,000. And this is the set of parameters that you have on average when it's partly cloudy. Likewise for rain, we define we give it a name. We say the cells we're going to change for that. Then we put in the values we expect when it's raining, much lower admittance, but costs are a little bit less as well. And then finally for sunny, same thing, the cells we're going to change, and then we put in the values for it. On a sunny day, admittance is much higher, but costs are a little higher as well. So with those three scenarios, once we've got them defined, then it's very easy to change. So right now we're in partly sunny. I can click show, and we see it stays the same. Now I'll click rain, and watch the values change in my model. So now we're losing $10,000 a day on rainy days. Let's go back to partly cloudy. We're making 81,000. On sunny days, we're making 187,000. So with scenario managers, what you're doing is you're getting different events that affect the parameters that you're going to feed into your model. So they've defined 3 events: partly cloudy, rain, and sunny, and 3 different sets of parameters, and you can see the effect that would have on your model. So we looked at this case of Middletown Amusement Park, and John Miller, the manager of Middletown, has developed this spreadsheet. And on a partly cloudy day, it's calculated to be show a profit of $81,000. And we see here some various scenarios, and notice how he's mapped out how the parameters change based on these scenarios: partly cloudy, rainy, and sunny. So John's developed these 3 weather-based scenarios, and the weather has a direct impact on 4 input parameters: the number of season pass holders who enter, the number of non-season pass holder, that's admissions, who enter the park, the amount that each of these groups spend on average, and the cost of operations. These are the things that will change based on the different scenarios. So the scenario manager allows us to generate a report that gives an output variable or set of output variables of interest for each scenario. And again, here's how we enter data into scenarios. And we put in the particular set of parameters for the event scenario we're entering, as noted in this particular slide. And then we can do like I did and just click the various values, or you can even create the summary report where it gives you that information all in one report. So the scenario summary report is shown here, and it includes the values currently in the spreadsheet, along with the specified scenarios. Okay, let's look at some other useful functions for modeling and analytics that we'll be using, some of them quite often. So let's consider a transportation problem that's faced by Foster generators. And this problem involves the transportation of a product from 3 plants to 4 distribution centers. The production capabilities for the 3 plants over the next 3-month planning period are known, and Foster has forecast the demand for the 3-month period for each of the distribution centers. The per unit shipping cost from each plant to each distribution center is also known. So we know the quantity we'll be shipping to our distribution centers, and we know the per unit shipping cost to each of the distribution centers. So what we need is to multiply those and sum them to get a total overall cost. And management, of course, has come to us and say that they would like to determine how much of its production should be shipped from each plant. And one of the things we'll need in order to do that is the sum product function. And let's see how that works. Well, it's a useful thing to do. So I'm going to go ahead and open up Foster. So a sum is a function that adds up all the numbers in a range of cells. A sum product is a function that returns the sum of the products or multiplications of elements in a set of arrays. So let's take a look. So we have 2 arrays or tables that we're looking at here. This first table right here is the per unit cost of moving from Cleveland to Boston, Bedford to Chicago, and so on. Down here is the quantity that we have to ship. to each of those locations, from Cleveland to Boston, 5,000, and so on. So in order to determine our total shipping cost, we need to multiply the Cleveland to Boston unit price times the Cleveland to Boston quantity. The sum product does that for us. And notice here's the sum product. It takes one array, in this case of per unit cost, and multiplies it by another array, or another name for an array is a table. Another table, in this case, the table of the actual quantity we're going to be shipping to each one of the different locations. So the sum product, we can toggle between, if you go to formulas in the ribbon and then show formulas and click it, you can toggle between showing formulas or not. So here we don't really, here we can see sum product in our formula bar. Here we actually see it in our cell. So this is convenience. It's one of the auditing tools in the formula ribbon. Okay, let's head back. So again, this is what we looked at with the Foster generators data set. And cells B5 through E7 contain the per unit shipping cost from each origin to each distribution or destination. So the origins are production plants, the destinations are distribution centers. And just as an example, it costs $2 to ship one generator from Bedford to St. Louis. The plant capacities are shown in cells F5 through F7. And the model is in rows 11 through 20. The total cost of shipping for this proposed plan is, as we went over, is based on using a sum product function. The general product of the sum product function is sum product of array 1 or table 1 and comma, and then array 2 or table 2. The function, sum product function, pairs each element of the first array with its counterpart in the second array, multiplies the elements of the pairs together, and adds the results. So in one particular cell, we're going to have B5 times B17, and then the next C5. So we're going to do the sums of all the products there. B5 times B17 plus C5 times C17 plus D5 times C17, and so on. So we're going to be multiplying the counterpart of each element in the tables with its counterpart in the other table. Okay, now let's take a look at the if and COUNTIF functions. And they're going to be quite useful also. We'll be using those. The general format for if is you have a condition, and that usually is going to be a relational comparison, greater than or less than or equal to. And also you can be combined together with various logical operators to make very complex conditions, like is A greater than B and C is less than D. Then that's the condition part. The second element of the function is going to be the result if the condition is true. The third, the result if the condition is false. The COUNTIF function, we give it a range and a condition, and then the COUNTIF will count the components that satisfy the given condition. So Gambrels is an example. We have a data set for them, and it produces car stereos, and it wants to keep its inventory to a minimum. And so it uses an order up to policy. And order up to policy is whenever inventory on hand drops below a certain level, enough units are ordered to return the inventory to that up to level. So let's take a look at Gambrels. And here we have it. And let's go to formulas and show formulas. So our model is quantity to be ordered is the order up to point minus the amount on hand. So for each, we have as our parameters inventory on hand and order up to point. And we've got some others as well, but these are the ones that are relevant for what we want to look at now. And then in our model, the order quantity is going to be equal to the order up to point minus the inventory on hand. And then the cost of goods is going to be equal to, and then we get a discount if our minimum order size is greater than, in this case, 50. So we're going to look at if the order quantity for this item, component 570, in B16 right here is greater than B10 or 50, then we multiply our cost in B6 times the discount factor. If it's not, then we just pay our regular cost. And then the output of that is we're going to have a cost per unit, and then we're just going to multiply that times the quantity we're ordering. Then we also have a fixed cost per order. So we do this, for C, D, and E as well. And we then are going to make a determination. If we're ordering, we have $120 cost per order. Well, we're only going to count something as being an order if B16 through E16 is greater than 0. So it checks each one of these elements, B16, C16, D16, and E16, and if it's greater than 0, it counts it. So that's an example of an if and a count if. Now let's take the formulas off, and you'll notice that actually we don't need to order any of component 741 in column D. So the order quantity is going to be 0, and because it's 0, it's not counted in our total number of orders. But these do count, and so we're going to multiply 3 times 120 to get 360. And then we add that into the other cost to get our total cost for the order. Okay, so again, here's that inventory model for Gambrel manufacturing. In the upper half of the worksheet, the component ID, inventory on hand, order up to point, and cost per unit are given for each of 4 components. Also given is a fixed cost per order. The fixed cost of $120 is incurred whether an order is placed, whenever an order is placed, regardless of how many units are ordered. The model portion of the worksheet calculates the order quantity for each component. Depending on the units ordered, Gambles receives a discount on the cost per unit. If 50 or more units are ordered, there's a quantity discount of 10%. And so we use the Excel functions of if and COUNTIF to do our calculations. The COUNTIF was used to count how many times we would make an order, and then we have to multiply that times the fixed cost per order. Okay, another useful function is the VLOOKUP. And this allows us to pull a subset of data from a larger table based on some criteria. So we have our VLOOKUP function. Value is the parameter. That's the value we want to search for in the first column of the table. Table is the cell range containing the table. And then index is the return value. So if you do find your value in the table, it's going to return what's indicated in the index. And then range, true, if you're willing to accept the first approximate match of value, and false if you're looking for an exact match. So let's take a look at this as well. And I will open up the Granite data set. Okay, and we'll share that. Okay, so here we've got the Granite Insurance Bonus Awards, and we'll go over to Formulas and Show Formulas, and we'll see how we calculate the bonus. If they're this percentage above target sales, they get this many bonus points. So we have a set of values here, ranges for different bonus points. From 0 to 10% above, they get nothing. 11 to 50% above, a 10-point bonus. 51 to 79, 15. 8 to 99, 0.8 to 0.99 is 25, and then 1 to 100 is a 40-point bonus. So we have our actual people, and here's their percentages above the target sales. So we want to find where 0.83 lies in terms of the lower and upper limits. And then we're going to return the bonus points that they would earn based on that. So we use a VLOOKUP. B15 is our value that we're looking up. And we're looking it up in this table A7 through C11, as indicated in this second parameter. We're going to return the value in the third column when we find a match. So for 0.83, we're going to look in here, and it's greater than this lower limit, and it's less than this upper limit. So it looks like this is the row where we match. So we'll return a 25 here. And then it goes on with the rest of the calculations. And so we get a 25 there. And that's to show you how a VLOOKUP table works. And then, of course, what we have in C15 that we just got out of the VLOOKUP table is used in the rest of the calculation to determine the bonus amount. But I want to focus just on the VLOOKUP at this particular stage. So here's that granite model. The bonus bands are in cells A7 to C11. Column A gives the lower limit, column B the upper, and then column C the bonus points awarded to anyone in that bonus band. In column C, the VLOOKUP function is used to look up the bonus band table and automatically assign the number of bonus points to each salesperson. So VLOOKUP assumes that the first column in the table is sorted in ascending order. So in summary, the VLOOKUP table with a range set to true takes the first argument and searches the first column of the table for the last row that is strictly less than the first argument. It then selects from the row the element in the column, which is the third one that you're going to return. Okay, and in addition to functions to calculate things, we have certain auditing tools that help us see what's going on with our models in our worksheets. So these tools are found in the Formulas tab in our ribbons under the Formula Auditing group. And they let you trace precedents and dependent, show formulas, which we've used a few times, evaluate formulas. So there's a number of things that we can do. Trace precedents. That's going to let you go back and see which cells pointing to the selected cells are part of the formula. Trace dependent cells shows cells pointing from the selected cells to cells that depend on the selected cell. So one is feeding in, the other is what do we feed out to? So both tools are excellent for quickly looking at how your model is linked together. So in Foster generators, we see their particular model here. And if you click on the trace precedents in the formula auditing group, you'll be seeing things like this, that, okay, a total or the unit price array element feeds into total cost, and the quantity array element feeds into total cost. So these are precedents for total cost. And then likewise, dependence on total cost are dependence on Lexington is going to be Bedford to Lexington. Total cost is dependent on that value, as is the total of cost to ship from Lexington and the amount from Bedford as well. So in this particular case, we've got units shipped from Bedford to Lexington. It's going to impact the cost function in cell B13. The total units shipped from Bedford is going to be in cell F18. That's dependent on the cell that we have clicked, E18. And then likewise, the total units shipped to Lexington is going to be dependent on Bedford to Lexington. So again, this is just a tool that might help you if you want to see what's going on with your particular worksheets. Show formulas is a handy one. And you can see the formulas right in the sheet. You don't have, and you see them all at the same time. Whereas if you click on a cell, you can see the formula up in the formula bar, but only for that particular cell. So this is kind of a handy tool. Evaluate formulas, again, is another fairly handy tool. And we can look at gambrels as an example for that. Let me open it up. Okay, and it's, there it is, coming up. Okay, switch over to this. So B17 is the cost of goods sold. And if you'll remember, you know, we've got this issue that we get a volume discount if we're above a certain minimum order size, in this case 50, but it's a variable. So let's go ahead and do formulas and then evaluate formula. And it puts our formula for the cost of goods up there for us. And we'll evaluate it one thing at a time. And the first thing it's going to evaluate is B16, the order quantity. So we get 95 for that. Then it's going to get B10. And of course, that's going to be the minimum size for discount. And that's 50. And then it's going to compare, is 95 greater than or equal to 50? True. So then we're going to be using B11 times B6. B11 being the discount rate of 0.9 and B6 being the actual cost per unit. And then we have that value. We're going to multiply that 4.05 times B16. And again, B16 is our quantity. And then we get our total amount. So again, evaluate. Show formulas are pretty handy. You might find them useful. Okay, so and here, of course, we're they've highlighted B17 cost of goods. We see that whole formula that we went through, and you keep clicking on it, and it keeps evaluating portions of it. So this is an excellent means of identifying the exact location of an error you might have in your calculation. And we have some error checking that provides automatic means of checking for mathematical errors in your worksheet. For example, if we have a hypothetical division by 0, you can get help on the error, and you can figure out what you need to do to repair it. And we can also set up a watch, and this is where we see how values change. And the user can monitor how a listed cell changes with a change in the model without searching through the worksheet or changing from one worksheet to another. And easy to set up if you're so inclined to do so. Okay, let's finish up by just discussing predictive versus prescriptive models. Now, we've talked about business decision-making is always dealing with an element of uncertainty. What-if models are descriptive models. They can be extended to deal with uncertainty. Predictive models can be used in Excel also. We can create predictive models using the regression tool, exponential smoothing, moving average. They help us come up with predictive models. And of course, we looked at those in the previous 2 lectures. What-if models help us deal with uncertainty, and we're going to be looking at simulation next week. So that's where we'll deal with another what-if model simulation, and we'll be dealing with Monte Carlo simulation. Prescriptive models can be used to make smart decision. This is optimization. After we finish with Monte Carlo simulation, then we're going to be getting into linear and integer optimization. And these optimization models are prescriptive, characterized by having an objective that has to be maximized or minimized, or in other words, optimized. And we have some sort of constraints. So optimization models are one type of prescriptive analytics. And Excel uses a special tool called Solver. And of course, the first day and the subsequent days, we did get that installed on people's Excel. And Solver is used to find an optimal value, satisfying the constraints and giving us the best result. So that's what we'll be covering the rest of the semester. Okay, any questions?